Today I need to go through, what was it? Oh, my name is different. I'll just do this while I still can. Whoops. There we go. Okay. Other than just looks cooler than the other, to be honest with you. This one's more useful. And it's taking a while. Usually it wouldn't have to take that long, but I guess it just wanted to. Okay. I should also move this closer. Can you hear that? Oh, surprisingly not. Okay, that's kind of cool. There we go. Maybe 5 megabytes? Close. Do, 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 do. You should also find a podcast to listen to. You won't be able to hear it, which is kind of cool. Okay. I can't spell. By Hannah Fry. It's the most useful podcast. So season 1 to season 2. Whoops.
I'm Professor Hannah Fry, a mathematician and podcaster, and I'm excited to tell you about the return of DeepMind, the podcast. It's the series.
You can hear it. Huh. It was on this whole time. That's why it sounds so echoey. If I
Where we go behind the scenes
Oh, that's
of
so
one of
sick.
the world's leading artificial intelligence companies to find.
Okay. They were recently talking about something to do with Alpha Zero and Deep Blue, I think. Yeah, Deep Blue AI. Um, so Deep Blue was based off human, I guess, techniques. Then Alpha Zero was based off of general techniques that it learned itself from playing Scratch. From scratch, a few billion times. Casually playing a billion times. Um, this is also taking a really long time. So I should probably start my work now. Dead. And do right. Okay. Speaking of which, okay, we have Win SCP. Please load. Nice. You don't get to see the password. There we go. Okay. What was it? I don't know. Literally nothing in here. Don't worry. Also nothing in here. Is there? Yeah, there's nothing. Novels are just this stuff. Light novels is specifically this, and academics is a work in progress. What do my light novels even look like when I open it? Close enough. Okay. Basically, as you can see, IB is a mess. Because technically there's only like 20 series instead of 133. So I fixed A level, and step is still a mess. The books are sorted, sort of all the papers are sorted, so I can quickly open a past paper. And then academics is just everything still. But this is also much better. So it's more useful. Which is why I have Further Pure open, because I need to go over some stuff which I specifically asked in AI not where I could learn, but what I should learn. This works in the background. Sort of. Don't need you. Don't need you. And I will be needing you. Why won't you open? Thank you. Okay. Start off with most basic part. Where was I? Overall, this is fine. Pre-2017. All of this, I want to change this from M to something else. I could just change it to dot, slash, or X. Ooh, I could find a funny symbol. Okay. Let me look for that. What could I use? I could use phi. Yeah, it's math, so I might as well use phi. They have it. Integral would be quite cool, actually. No. Real F. Could use alpha and beta, which would be quite smart. Misclicked. Okay. Don't need these. I might just go for this. Actually. Something stupid to work for. Okay. Oh, bless me. It actually works. Okay. Natural numbers is a bit. Integral sign makes it look cooler. Okay, I'll think about that later. That's quite good to know. I want to work for, I don't know how long, so I'll just set this around. All I have to do is go through this. Number theory. I need to go through diffusion theorem quite a bit. Euclidean algorithm even more, because I suck at this. This I don't think I need. Modular arithmetic, it's very useful. Use Fermat's little theorem, it's very useful. The rest of this won't be counting, so very good. Division theorem, this is some GCSE site top, so it's just fleshed out. Number theory is the study of systems and properties of numbers. Of particular interest are the systems of integers, such as the integers given -3, -2, -1, 0, 1, 2, and 3, and so on and so forth, and the system of natural numbers given 1, 2, 3 to infinity. The concept of divisibility is very important in number theory. Okay, if a and b are integers, with a being exactly equal and identical to 0, then b is divisible by a. There exists an integer k such that b equals a or ka. In this case, we say that a divides b and denote this by a factor, or a divides into b. That symbol literally just means divides into. Quite useful if you don't have to write out divides or factor every time. If a does not divide b, then we write a not divide into b, obviously. Given that, I should say, in the past you have only considered the positive divisors of a number, but the definition above applies to both positive and negative numbers. Okay. A is also called the divisor or factor of b. Yeah, that's quite normal. And that a factor of b show that minus a or negative a is a factor of b. So that's in the situation of a being multiplied by -1, and -1 is the constant k. So b equals k multiplied by a for some integer k, which we know is -1. If k is an integer, then minus k is also an integer, and b equals minus k minus a. So obviously minus a is also a factor of b. This is just normal math, like this GCSE. So you're going to check if there's some number that you can multiply by 11 to get 143 and so forth. There's not really a special technique to this. It's just maths, normal math. Obviously, something like this isn't going to work because it's 5 and it should only enter 5 0, which comes in modular arithmetic a bit later. Ooh, good. What went wrong? I'll figure out later. Anyways, where were we? Yeah. Yeah, this is just normal stuff. Also, for a to divide b, b must be less than or equal to a. Otherwise, you'll get an answer of which is a fraction of which is also obviously not an integer. As an integer can be represented as a single number, not as two separate. The relationship between two separate numbers. Find all the divisors of 8. This is just simple maths. 1, 2, 4, and 8. With the negatives because you divide by them and they're the exact same thing, but negative 11 is obviously prime. So it's just finding prime factors. To be able to find the following probability for any a, b, and c in the sets of integers, it's just not positive, it's just all integers, with a not being equal to 0. A is a factor of a, every single integer divides into itself, as you can see here, which is just obvious logic. A is a factor of 0, because 0 is divisible by any integer. Or you can do 1 over 0 and 2 over 0. No, the other way around. 0 over 2, 0 over 3, and stuff like that. If a is a factor of b and b is a factor of c, then it implies that a is a factor of c. If it's something like 2 is a factor of 4 and 4 is a factor of 8, then 2 is a factor of 8. Simple maths. A is a factor of b and a is a factor of c, then a is a factor of some multiple of b plus a multiple of c, which is a bit hard to understand, but requires an example. I would love to see, but they don't have one. For the example later on, a is a factor of b, which implies and is implied by a factor, a multiple of some number being a factor of some multiple of b, for all integers. It has to be the same multiple though. So for instance, 2 is a factor of 4, then you can multiply both by 2. So your multiple of whatever, you're scaling it by 2. 4 is a multiple of 8. So there's just the biggest number that goes into both of them, essentially. Greatest common divisor. ABC for all integers z, prove they have okay. It's just normal then. Okay, I won't have to do this either. The result is always an integer. However, the quotient is not necessarily an integer because I can find with the quotient and remainder for any two integers. Okay. A and b are integers such that b is greater than 0, then there exists a unique integer q and r such that a equals bq plus r. Oh, that makes sense. Quite weird to understand. With 0 being equal to or less than r being less than b, because obviously you can't have some integer of a given integer being more than the original integer. With values a and b, set q equals to the greatest integer that is less than or equal to a divided by b. That are equal to a minus b. You call q the quotient and r the remainder. You can also, that's good to know. Really good. Okay. Division theorem. We could try applying here. Use to find all the integers at 9 to 4 equals 13q plus r. 7. Literally just finding the remainder. You're smart. Okay. Therefore, integers n squared leads to divides by 4. This is where it becomes really useful for really, really quick proofs. I could not do at the moment, and I also don't need the algorithm yet. Find the quotient and remainder when 200 divided by 7, so that'll be 140 plus 49. 119. Remainder of 1, I'm guessing. Let me check. There's no calculator that wouldn't just tell me. 7, so we should get a really weird number. Why the flip is... Oh, this is quite interesting, actually. I wish it would go faster. 3.141596. In the meantime, what was it? Wait, is it Pi Day? When is Pi Day? 14th of March. Oh, it's tomorrow. Okay. Good. What was it? 28. What did I get? I did 140 plus 49. That's 20 plus 7. No. 7 times 7 is 49. 20 times 7 is 140. So 27. I messed up. Oh, I messed up. If it is 189 plus another 7, which would bring you to 196, which is just 14 squared, which I should know. Okay, so 14 squared, so that would be which is just 28 times remainder 4, I believe. Okay, please tell me if I'm wrong. I don't care. These calculators are really useful. 7, 28, 4, nice. 3.4159653. Is it 141592665? Okay. Prove that if any used one of this form, 9k. Prove or show that the square of an odd integer is in the form ak plus 1 for some integer k. That's quite weird. Euclidean algorithm. Okay, this is the one I'm most excited for, or at least interested in. Oh, it won't let me do the rest. Euclidean algorithm. You can use definition to release the right form definitions of common divisors, greater common divisors k. Yeah, GCD from if a, b, and c are integers and c is not equal to 0, then c is called a common divisor of a and b if c is divisible by a and if c divides into a and c divides into b. If a and b are integers, then at least one of them is not equal to 0, and at least one of them is not equal to 0. Then you'd find the greatest common divisor of a and b as the largest positive integer which divides a and b. Greatest common divisor of two integers a and b is a positive integer d divides. Oh, okay. That satisfies positive integer. Yeah. The correct b is a positive integer d that satisfies two conditions: d divides in a and d divides in b. is common divisor of A and B, then C is less than or equal to D. The greatest divisor A and B is written as GCD, A and B. A and comma B, sometimes the highest common factor. There we go. Normal GCSE maths. Obviously, this is just 3, and this would be 25, and this would be, which you just do mentally. Again, addicted to that. Yeah, in GCSE mathematics, you found the greatest common divisor by writing the numbers as the product of their prime factors. However, writing a number, the product of prime factors, can be very time consuming, especially if the number does not have small prime factors. Euclidean algorithm provides a method for quickly finding the greatest common divisor of any two integers. Is where I would most likely get stuck. What was I going to do? Oh, right, it's done. Sure. Hit my samba. Oh, that's fine. I'll eat in a bit. Okay, this is still going. Please hurry up. Yep, I'll eat in maybe 20 minutes. Okay. Whoops. Here we go. Merci. How long are we going for? Not long. 8979. Oh, 926 535 823. I think I made a mistake here somewhere. Over to a 323 feels wrong. Anyways, that's fun. What was I doing? Right. So I can't close this yet because it'll close this. Given positive integers a, b, with a being equal to or greater than b, apply the division algorithm to a and b to find the integers q1 and r1 such that a equals q1b plus r, where 0 is less than or equal to r, which is less than or equal to b, obviously. R1 is equal to 0, then b is factor of or divides into a, and the greatest common divisor of a and b, b. It's basically saying if you have something like, if you have 4 and 8, all goes into 8 without a remainder r, in this case, we're basically saying a can be represented as some multiple of b because it's less than b. If you had 4 and 8, 8 is 2 times 4, but if it was 9, it would be 2 times 4 plus 1. So you just a remainder, basically remainder of normal maths. If r is not equal to 0, do the process, resolve equations. A equals 1 q1b plus r1, b equals qr2 plus r1 plus r. Okay. This is the part that gets, you'll see with the first one. Yeah. So it's the process less than divisor. Yeah. So increasing the range, decreasing some of the range of non-negative integers needs to terminate at 0 in a finite number of steps. The last non-zero remainder in the sequence of greatest common divisor. This is a Project Euler problem. Pretty sure. Or Project Euler. Sign in. Merci. 5, 8, 3. Where is it? Fibonacci multiples of even 3. Find some of the multiples of 3 and 5. No, not that one. Largest prime factor. There we go. This. You're meant to use this thing, and then create a while loop until it terminates at r being equal to 0. I sort of want to test out, but I got the answer by brute force. I might test that out now. Remove. Oh, oops. Okay, this compiler. Gonna work with me or cool. Broken. Okay. There we go. Okay. Prime factors of largest prime factor of this. This greatest common divisor of this and ooh. Never mind, that will take too long. This, so it's an iterative process. Sense. So obviously it just shifts one space each time, if that makes sense. Start with u and r being equal to 1, then you start with move to your r1 over here, just dividing into this. Then you're dividing into it again with a separate remainder. Bear in mind, this identity, this and this, this and this are unique, which is something you'll just come across. Just normal math, yes. So the Euclidean by the greatest common divisor are 3 of 6 and 5, 6, 5, 7. So yeah, that makes sense. You'd sort of have to guess. They started with 2, so 6, 5, 7. Yeah, then your final value of r over here, provided r be n plus 1 compared to r to the n is 0, then the greatest common divisor. And the greatest common divisor is smaller than the previous divisors that do not work. Quite smart. So if I had 376, so draw out. Probably prettier. I had my sister is loud. In the meantime, probably really boring. On something that looks semi-cool. I have on here. I think. Kuma is running. Kane is running. Okay, sleeping. Last thing, yeah, probably anime because I've been needing to complete like 5. So this is collection. What anime did I add? Added 5, all of which were above 5 gigs. And as soon as I add more movies, I'll be more happy. Then I'll actually in a server. So this feels like enough anime for someone to watch now. A few more later, because this is 300 gigs of it. Too much. This is not what actually. This is amazing. Amazing. This is. Here's what it is. This is terrible. Don't know why. It's amazing. This is terrible. Amazing. Everything else is pretty much good. This is not PG. I think. Yeah. This rating be. It's not actually, but like, I don't know. seem good. Anyways, what was I doing? Down. If I can. Okay, what? Okay. I need a pen, and I need a. Okay, without a calculator. So, if I wanted to find the greatest common divisor of such, there's probably questions. 143252. Okay, gonna do. Okay, do it for A and B, and then you do it for the remainder. Yeah, so you test A. Okay. Do 7 is obvious. Need ugly number. 1292. Okay. Um. Oh, are you nice? Okay. Do that in caps because it looks weird, but it's fine. What was it? 129284. Obviously, starting off step 1. 84 is less than. It's not equal to. It's clearly less than 1292. We're going to let or at least we're going to treat 884 like B and 1292 like 8. So 1292 equal to 816. It only goes in once, unfortunately. 1 times 8, 4. So from here it's just a fraction. I could do this mentally, but I would probably fail. This is going to be a 0. Nice. Okay. Why am I doing? Why am I blanking? What's going on? Okay. Basic subtraction. So it's just 292 plus 26. No, 16. Which is equal to 300 and 308. Yes, I am taking step. Wait. 400. Oh, I read it wrong. Forgot that it wasn't. Yeah, okay. There's the. There we go. So 408. And from here, you do 884, I believe. In the iteration. Yeah. Okay, that makes sense. The second remains. Okay. 4, 8, so that's 2 times plus. That'd be difference. Why can't I do subtraction? Why am I blanking so much? Okay. So it's 68, I think. 807. Yeah, yeah. Yeah. Don't want to make a silly mistake. It was bad. Okay, don't do something stupid this time. The next one would be 408. Is equal to how many multiples of 68? I reckon I can get 5 in 6, 8 times 5. A weird thing. Just do times 10 divided by 2. So that would be 300 and what was it? 90 times 340. I don't trust myself. 465 is 30. Oh, okay. Myself that 340 plus another 68. Okay. Oh, that's 6. Oh, okay. So it's just 1 times 8 0 divisor. Greatest common divisor of 1292 and 804 or 268. That's an interesting technique. What are they going to do? I'm going to check. It actually exists. Calculator Super's the best. Separated by base. So 1292 848. Nice. Just gonna remember this. Don't know. Something. Okay. I will test it with another one. Or at least I should test it with another one just to be sure. So this I don't like, but it's useful for step. Version 6. What the flip? So 9 equals. Okay. So you basically find numbers that could be. Oh, I don't like that though. No. No, 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 no. The only thing they test. Okay. Yeah, it's useful. I'll learn it anyways. The integers x and y such that mean 6. Find x and y such that 306x plus 608 657. Okay. 57 y is 9. Obviously, we know one's going to have to be negative. Most likely, the x value here could be the y value. No, it's the x value. Okay. What do they do? For the example 8, we know the greatest common divisor 9. Let's say in fact I should do that now. So 657 equal to 2 times 306 plus that's 612. So 57 equal to 12 equal to 45. That'd be then 306 equal to how many multiples of 5? I could do 9 times 9, 81 divided by 2. Just do 306 into 5, or 45 into 306, 590, 180, 270. That sounds like 6, I think. Do 270. 5, it's obviously going to go over. 590, 135, 180, 215, whoops, 270, what did I say, 225, 270, that is 6, yes, I could get it very wrong, that'd be 30, 36, then 45, how many 36s, 0, what, okay, they got 9, 1 times 36, that's 9, what am I on about, spouting nonsense, 6 plus 9, obviously 36 equals 4 times 9. I don't know why it took so long on that. 0 implies greatest common divisor of 6, whoops, 306 and 657 equal to 9. Useful technique, yeah. So I can write over here ED of 306 579. So that would apply for the same. But I can technically do x 657y 9, because if we learned previously, a factor of b and a factor of c, and b is a factor of c. It implies a to the n, or a multiplied by n is factor of b multiplied by n, or multiplied by n, and b and it's factor of c multiplied by n. Okay, so basically using that logic, you don't need to calculate n, you're just calculating numbers that work. Also, yes, new ASMR for you to fall asleep to, apparently. What do I even say? It would be boring. Oh. Anyways, what's the thing? Distracted. Implies that 9 is a factor of both of them, which means 9 goes into divide by 9. 9 equals 45. What? What? Oh, okay. That's not 45. Okay. So this is the part that screwed me over for a second. 9 is the greatest common divisor, so beta's identity of x and y must exist, obviously, because they're just multiples. Even if they're separate multiples, they're still multiples. But back steps. algorithm, for example, 8 rearrange 45 equals 9. So 45 take. That's genius. Okay, like that. That's stupid, but it's genius at the same time. I feel stupid now. We're basically saying, well, you know the two numbers, two multiples of 9. Why not just rearrange to say, what was it? 55 take 1 times 9. And from there, you know that's equal to 9, which isn't very useful. They do. 9 take. Why though? 45 equals 36. Yeah, rearrange 360 to 45 times 6, 36. Right, 36. 5. You do the same for. They actually do though. 45 take 306 minus. Okay, so they're just rewriting each one, but they're literally working backwards. We're saying 45 take. What was it? Oh, over 45 equals this. And from that, we can say 45 equals 306 take away 36 all over 6. What? How did they get rid of 6? 306. Oh, it's just 36. Bugging. So it's just 306. I need better handwriting. 306. Take away 6. Well, 5. Okay, that makes sense. 45 is equal to some other number times some other number. 7 times. Yep, so from the previous result. So this implies this, which implies this. Implies 7 times, was it 7? This is 6, 5, 7, 2, 306 minus 6, 5, which sort of makes sense. Okay. Where do they get the 7 from the. That's where I'm confused. They multiply by 7. Where was the number 7 from? Where the flip did they get 7? 306. I didn't mess up, I don't think. 45. 6, 5, 7 take 2, 306. Yeah, so where did 7 come from? They take bracket. Oh, that's smart. Okay, should have read that clearer. This, and just move out the brackets, so you get 6 lots of 45 plus 5, which is 7 lots of 45, which we rewrote as this mess over here. So we can clearly see that it's just 7, 5, 7 take 2 times 306, which is where you just finish it off and simplify. which they did very cleanly, which I didn't do. I don't know why they did it that way though. It's 657 take 236. Oh, because they can just take out the brackets. Then take this times this, so that's minus 14. 306. Take, we already removed this from the brackets, so that shouldn't be there. Minus 1 lot of 306 implies 7657. Take away 15, 306. So obviously equals minus 15. Like 7. That's so sick. That's a terrible line. Or box. Line. Oh my goodness. Okay. That's really useful. I didn't think that was a thing. So essentially what we're doing is reverse engineering the theorem. Well, it's not really reverse engineering, you're just reversing the theorem. You're going backwards to find the possible values for which that multiple would exist and you have two separate values. That's so useful. So in cases where you have to solve values, you use this because you know the greatest common divisor. Okay, this only works for if you have the greatest common divisor. Oh, you took a break. Good job. Okay. Really proud. Really. Right? Because I'm not gonna cry. I don't think. Hopefully. Anyway, what spell? I said a well. Anyways, I'm gonna try another question. I want to start from scratch there. Use the Euclidean algorithm to find x, y, the set of integers such that. Okay. Let me just. I'm just the option. Part 1, things find the BC. The of 143 and 252. The greatest 3, 5, 2. Pretty sure it would be calculating normal math, so you wouldn't even need to do this, but further useful for really long strings of digits. So we can say 252 equal to 143 times 2, 280, so that's 1 times 3 plus some number, so 252 take 143. There we go. Yeah, it looks more normal now. 252 143, so it'll be 67 plus 52. That'd be 109. I think. Yeah. Just if I get it wrong, I get it wrong. Can't really fix that. My mental math isn't the strongest. Equals 1 times 1. 3645, so the 34. What am I on about? Yeah, 34. 109 equal to 34 times 3 is above. Is it? For some reason I can't tell. Oh, it isn't. 3, 34, 1 and 2, so that'd be 7, and obviously 34 equal to um 4 times 7, 1. Yeah. Why did I say plus 1? 28, 6. Then 7 equals 1 times 6, 1. 6 is equal to 1 times, or 6 times 1. Which implies greatest common divisor of 143 and oh, there we go. 143 and 52 is equal to 6. Okay. Now I need to make sure before I do the second part and I get it wrong. Because it's just practice. Greatest common divisor calculator. Okay. What are the numbers? 143,252. 1. Really? Wait. Oh, I'm a muppet. Why would I do that? I wrote it like this on purpose as well, because I knew I'd mess up. This is your remainder. It's the second remainder. Well, this first remainder, second remainder. Or the other way around if you like. So it's 1, not 6. Literally every single question. Have I? Okay. Cool. Then from here, 12. I'll find and I goes 143, 3, I believe, plus 2521. You know what else we do? 1, 2, 5, y. Okay. Then for it's equal to plus 5 to 109 that. So I could technically fit this, both of them. That would be actually oh second 55 143 plus 109. I could write 143 out differently. There we go. Equals 5 take 109. This is just 143. Am I thinking this? Definitely am. We do last time. So we took 45 take 36 equals 9. Because it just, I haven't started from the last step. Okay, that makes sense. I have to work my way up. What I was missing. Why didn't I do that? Why didn't I do that? You don't start from the 6th time, you start from the first time. Okay. So we got equal to 1, and 1 is equal to this term. Take this term. Am I bugging? close U. That'd be, yeah, just 6. I don't want to make a mistake. That's stupid. Whoops. Take 1 multiplied by 6. And 6 equal to 1 multiplied by 7 take 1. That's 6 minus 6, which is equal to 34. Take 28. No, I should do it as 4, 7 minus 1. Okay. I might be doing something. That would then apply 6 take 34 can be written as 109 take 7 divided by 3. Am I bugging? 7 can be rewritten. Yeah, I'm doing something wrong. Okay, I need to think. Start from the beginning. Okay. Even ignoring this. We have 109. This we don't need. 6, 7 take 1. Is that correct? 45 take 36. Okay, I'm doing it wrong. We just need the remainder. 7 take 1 times 6 equals 1. Correct. And you've got 7 equals something. I'll just leave it at 7 take 6. We'll keep the 1 there. 6 is equal to 34 take 4 to the power. Okay. 34 take 4, so 7 equal to 1. Okay, done in pink. 7 take 34 can be written as something else. So 34 can be written as 143 take 109. Where do things appear from though? They just do. Okay. I should know that. Earth will take 4. Okay, I haven't done anything wrong there. 7 is also equal to some stuff over here. I'm not bugging. That's just true. We did it once, all the way to the top. We do it twice, all the way to the top. Okay. So we've got 7 minus 4, so 7 minus 5, lots of 7. I'm not done. So minus 5, 7, take away 143, take 109, should give me 50 something. No, 40, 36, there we go. 34. 1, 7 can be written as some large thing. We went straight to 7. This one I just went nuts. 45 equals 106. Oh, it's a remainder. I have to start from 7 equals 109. Take 34. That take that, which equals that, take that. So that's minus 5, 143. Take 109. That. Oh, I'm not done. Okay, that's why I was confused. I could leave this. I should. Okay. That's minus 3. That's why. Whoops. So minus 3 multiple 7. Take 34. 34 is equal to 252. Take 143. There we go. Okay, this simplifies to 109. Perfect. Did we write it 06? What did I do to get that? Confusing my reason. I just need to remove 143, 254. So all of this implies thing. Or there's some sort of implication going on. So from here, minus 3, 7. What would go there? 7 equals 109. Take 43. 34 times 3. Um, 254. 1 lot of 254. Take away 1 lot of 143. I want to end up with 143. Yeah, on one side. 1. I need practice. That's 109. I don't want to change at the moment. 3 times 143. I simplify that. Waste of time. I need 109. 109 equals 252. Take 143. Nice. Minus 3. 252. Take 1. What was it? 2. 143. Minus 3. 34. Minus 254. Take 134 equal to 1. Whoops. 143. Okay. And from here, minus 3 times 252. What's that times 3? 2 carry that. 9, 10. 102. 102, take 143. I'm missing something. We do. I didn't get 102 over here. 1 over 2. I'll just give me 1 and be written as that. So I need am I missing? And can be written as 109 take 3 that. Okay, and 109 can be written as 143 7 is written as 109 take. Yes. 109 is written as 252 take 143. We're subtracting 7. Okay. It'll be, yeah. I'm overthinking something really stupid. 252 take away 143 gives us 109. So it is equal to 7. This 134, or is this 34 that annoyed me? What's 9 times 34? 306. A coincidence? I just multiply it wrong. Probably. Don't worry about that. Waste of time. Take away 3 lots of 34. Shall find a way to change. Minus 254. Take away 1. Take away 3 lots of 143. Take away 143. Still the annoying one. So p positive 9. That's not what I want. 43 equal to 143. Take 109. 9 could do minus 3 still. 5 to take away 3 times, what was it? 34 is equal to 143. One four three we can take out. 109 I can change. 109 plus 252 take 143. 3 5 times take 1 4 take 1. Oh no, I messed up. It's basically saying 143 be written as 252 take 109. Because we got to 252 take. Oh, there we go. Okay. I have 3 sets of brackets. 1 2 3 2 1 0. What's the 1 2 3? Okay, sure. Take away gives us minus 3 2 5 2. That'd be minus 3 of that, so minus 6. I want to get the question right. Take away that minus 6. That'll be plus, no, minus not. Doing something stupid. Times minus 3. That would be minus 3, 9. So minus 3. So it's just 6. 6 sort of 2 2 plus minus 6 18. 109 is not what we're 18 lots. 9. What did I do? 143. Why did I change this? don't even know if Solution has it. I'm majorly overcomplicated. Thank you. And points. What was I gonna say? Okay. It's a math cheese. Have it. If you do, please. Beg. Need to find this. Oh, that's me. Not 1A. What's an example? Just take the example. Minus. Okay, minus 5, 7. 1 equals 7 minus 6. Correct. Okay. I just start from the wrong point. No, starts from the right point. Equals 1. 7 take. Extrapolate. 1. Bit by bit. Oh, okay. 1 and 9. 34, 1 and 9. There you go, 143. Then you get 252. Okay. I was getting there. Incredibly long. I'll take a mini break in a bit. Okay. Back. Stupid. Okay. Starting from scratch. One is equal to 7 minus 6. So 7 minus 6. 1. Correct. 6 is equal to 34 times 4 lots of 7. That gives us 5, 7, or 5 multiplied by 7 take 34. Okay, next step. Take my time. 34 we can rewrite. 7 we can rewrite. What's 7 equal to? 109 take. So it'd be 509 take away 3 times 34. Means we're saying that 5 lots of 109 take 4 lots of 30 equal to 1. Okay, we're getting somewhere. 34 is equal to 143 equal 109. One, 4, 3, take away 109 to 1. So we know that would basically just be 909 or 1. Correct, I think. 109 is equal to 252 8143. Okay, 4, 1, 4, 3, 1. So 9, 2, 5, 2. Take away 9, take away, W take 13. That's definitely wrong. There's no way. What did I do wrong? Did I multiply something wrong? Can I just not? No. Oh, doing it right. I made a stupid mistake. I know what to do. Okay. 5, 109, 34, we were right. It's this stupid step here. That's 5, 10, take away 15, take 1, so that would be take 16, 34, equal to 1. We just wrote 7. Now I can rewrite 34. 34 equal to 143, 109. Equal to 1. So 16. That's 21, 109. Pretty sure. 16 plus 5 is just 21. I'm having to check that. That's kind of sad. Minus 16, 143. We can leave this here. Is that correct? So far, yes. Okay. Equal to 1. Then 21, we can change to 21 lots of 252 take 143. Take 16, 1, 3, 1. From here, 21, 5, 2. Take away 21 plus 16, 37. I beg I haven't multiplied something wrong. Yes. That was my actual sound. Remember which way around it. 143252. Yep. Minus 37. Y equals 21. Okay. Taking a break hold. The most simple thing. Um, oh, your phone keeps falling. Oh, for goodness sake. Yep. Yep. Okay. Oh, time to take another extended break. Again. Okay. Need to hurry. Anyways. Find a step question then. Flip's sake, okay. I have it in my bag. One sec. Who doesn't keep questions in their bag? Wasn't in there? Why? Okay. Where it isn't. Okay, cool. Could be. Mm. What you do? Your feet. One has nothing to do. One is found it really quick. Okay. I have to write this out because I don't have a scan. Essentially, question goes as follows. And close to the mic as well. Sounds, I don't know, more podcasty, people say. I guess people say that? People probably say that. Anyways, you do have to do something before that, but I'm just going to skip it. Prove. Yeah. No. Oops. No positive integers, so that's that. X squared plus 5y equals 203. Can I do this with this? Looking for values of x and y. If you have a 1, then you'd have to square root x. So I'm going to change x. So first of all, now we just have u as a constant. So we have u and y. Or u and v would look best. Do p and q. P, Q, R, S, R. X squared and y. Okay. Starting off, we need to create some divisor. That mess. Did you do that? Would that work? No, it wouldn't. At least it wouldn't be easy. No, Chinema. Anyways. Hmm. A bunch more. To introduce be a relatively prime if the AB 1. Okay. That makes sense. Oh. Okay. Chidima, no. You keep. Good example of if in that statements, then it can be also represented as can you hear me at all? Oh, you can. Okay. Um, simple implies and implied by. When implied by A plus by equals 1, then A and B are relatively prime. A and B are relatively prime, then A plus BY equals 1. Okay, cool. And 2 instantly A and B are relatively prime. Greatest common divisor A and B is 1. That makes sense because the only pods either would be 1 only. Prime. Okay. Which is A and B are relatively prime if and only if there exists X and Y such as A is divided to 1. Nice. So that relatively prime that you do greatest common divisor equals 1 equals 5, so it'd be 5 times. I'm going to try on my own. We're going through another one. Yes, I did cut off part of it. Okay, A. A. We would start off with 60 equals 1 times 40 plus 20. 40 equals 2 times 20 plus 0. It was 49. Oh, where I went wrong. Wondering. That'd be 9. 2 times 9 plus 2 times 1 plus 0. 5. Greatest common divisor. 49 and 60. 1. Which further implies or implied by the thing. I wish there was something like this. Then actually it's relatively prime. You can start recording. Yeah. Yep. Okay. So we know they're relatively prime. Part B. Find x and y such that a 49x plus 60y equals 1. You could guess this. Like I could guess 2 and 1. But it's not a good idea to guess. That we have 1 equals, we take what? Flip. Okay. Messing up on this step. Need to remember. You add 1. okay, we know this. From this we can get 3 take 1 just means 1. We can also get 2 from here, which is 20. Take 2 lots of 9. 3 doesn't appear anywhere. Yeah. I'm starting from the wrong one. Why? Something was up. I need something here. I need a 1. So I need -1 somewhere. How am I going to do that? What did I do? Okay. 7 take. I got remainder 1. I have remainder 2, so I do times 1. I guess. I don't know. 1 equals 11 take. 2 times 4. Where did that come from though? I wrote it wrong. It also stopped accidentally misclicking. Didn't send anything. 9. I do wrong. 9 plus 1. I left it. Okay. I got it partially right. And how I didn't see that. Plus 11. That'd be 49 to 54. So that'd be 4 times 11. 5. Then 11 is equal to 2 times 5. 1. And then obviously 5 to 5 times 1. Hence the implication of 1 being the greatest common divisor. Okay, now we can start. We have 11 take 2 5 1. From here 11 take away 2 lots of what was it, 49 take 4 times 11 1. That's 9 lots of 11 take 2 lots of 49 1. What did we have? 11 is equal to that. Okay, we have 9 lots of 60 take 49 take 2 lots of 49 1. Finally 9 lots of 60 take away 9. That's 11. 49 equals 1. Therefore equals to, I did it backwards, that'd be plus 11 is equal to 9. Correct? No. Minus 11, 9. Okay, I don't want to see that part. And the integers pq such that equals 5. Part I'm confused by. I'll do that. Nope. Okay. So I should first write it. 49 e. I think I didn't use p earlier. Plus 60 q equal to 5 times 1. There's 2 ways I could do it. Or I could start from 5 because we have 5 in our sequence of things. That'd be weird. 5 equals 49. Take lots of that. So try 49. Take 4. Equals 11 is equal to 60 take 49. That work? That would be 49 for minus 3, 9, minus 4, 60. Definitely not something wrong. Oh, unlock it. Positive. Don't know how I missed that. I guess I just thought it was a normal number. That would imply E is equal to minus 4, Q, whoops, equal to 3. There we go. Did I get it right? What? What? How is this not correct? If I try this now, 49 or it's just 6, carry the 16. Okay, you got 60 times 4, which is just 240. 240, take away 196. Are they positive? They only be positive. Integers, they'd be integers. That'd be 5. No, it wouldn't. That would not be 5. What did I do to get this? I still do that. Oh, you took a shower. No comment. I'm recording a video. I can't comment. Okay. Clearly I did something. Full time 11. We start from the beginning. Really satisfying. Anyways, we have 5 equals 49. Take 4 lots of 11. I'm not wrong. Then 9 is equal to 60. Take 11. Minus 4 lots of 11 equals. That's why you do one time. 9. Wait. I'm on the wrong side. Take 11. Take 4. 11. 5. You get 60. No, take away 5 lots of 11. Minus 5. Okay. From there, 60. We have 60. And change 11. Take 5 lots. 11. Take 40. Equal to 5. I'm going to check. 11 times 55. It's correct. That's minus 5, so it's minus 4. Minus 5, 49, so plus 5. Minus equals 5. So saying minus 2 plus 9 times 5. Actually, divided by 2. 5, I think. 1, 8, 9. Ahead, let's go. So is this not true? They get 55 and 40. Ever benefit. Literally saying 49 lots of 60 minus 5. You're wrong. 49 plus 60. The order doesn't even matter. Just need 2 integers that satisfy that. Multiply by 5. That also works, but you wouldn't need to do that. Okay. So they get greater multiple of both. Weird. Except that I did it better. This is just 7, 20, what is it, 1836? 90, 90. Yeah, Grace comes by the P46, where 3 possible values. 3 possible values before the greater common divisor becomes 42. Something's greater than 6 and less than genius, greater than or equal to 4. They're called technique. Again, so if we do equals 42, something get remainder. How are you going to do that? Solve. Test it. I won't do it. Being the common divisor e into 2 is 6. So 42 equals xp. Nice thing. Wait. 6 to 7 is 42. So that would just be 3 times 6. 1 times 6. 3 times 6. It could be 6, 12, 18, 24. No, semi-also was a 6. So 6, 12. Yeah, 6, 12, 18. And check. So 42 equals 18, 36. Only go twice. 2 times 18 plus, what was it? 6, 4, 6. 18 equals 2 times 6. Yeah. So quite a cool question, I guess. So 143 and 910. Now what are the questions there? Find simple divided to 2. In the simplest form, that's sick. Beginning. Okay, that makes sense. Okay, modular arithmetic. We've only been here for 1 hour and 45 minutes. Okay. This is the thing I hate and love the most. Modular arithmetic is a system of arithmetic that is restricted to the remainder when integers are divided by an integer called modulus, or called the modulus. You can visualize the case where modulus is 12 by looking at hour hand on standard clock. Okay, 5 hours afternoon, the hour is 5 o'clock. After a further 12 hours, the hour hand points at 5 again. 12 hours have passed in total. Arithmetic modulo 12. The number 5 and 17 are congruent. You write 5 equals 17 mod 12. So the remainder. Oh, okay. I think that makes sense. So 17 divided by 12 is 1. So 1 mod. Remainder 5. So after 1929, that'd be 1224. So it'd be 2 of them. So 5 equals the fudge. Wait, no. No, that makes no sense. Okay. Gonna take a mini break. Okay. Very good. I'm going to read it again. Restricted to the remainders when integers divided by another given integer called modulus. Points at 5 o'clock. The further 12 hours and 0.5 again. 17 hours passed. So in total, arithmetic modulo 12 numbers 5 and 6 5 equals 17, 12. That sort of makes sense. So the next one, 29 hours, 5 equals 29 mod 12. Basically, you're saying 29 over 12 remains 5 each time. I think, okay. 9 is congruent to both 17 and 5 modulo. Let m be a positive integer a mod to b modulo m is a factor of a. So, if that makes sense. Modulo b, then you write a equal to the same as b mod m. True or false? 9 equals 9, 5. 4. Okay. Fine. Why did I have open? Okay. I spelled that wrong. Arithmetic. Brilliant. Thank you. Boy. Okay. Second break. Of arithmetic, which consider the remainder must be around 6 quantity. Modulus remainder multiplied to prime numbers, for instance, theorem, Lucas theorem, and cryptography. Cryptography is something I do need to look at. I haven't. What? Was it complete? Oh, where's Wilson's thing? I'm not gonna learn that. Tuesday module 12-hour clock. If it's The clock now then in 5 hours, the clock will go 3 instead of 15. The remainder 15 modulus of number x n is the equivalent of x when divided by n. Oh. Okay. I need to use Python. So I went. They were saying so if we have 5 equals 17 mod 12 and 5 is equal to 29 mod 12 because it goes in 5. So you literally say, well, I'm so stupid. Really, that's such a. Okay. I don't know why brilliant is what got me to understand that. The end of the second. Okay, makes sense. What? Both are true, but okay. 24 equals 9 mod 5. That's 15 divided by 5. Okay. 5 equals minus 11 mod 8. That would be true. Minus 17. That's just 13, which wouldn't work. That makes sense. A, B, A, and that equals possible values of n. So you could do anything, any multiple n. You could do. Hmm. N can't be 10 though. Oh wait, it can because 0 is so 10, 13, 19, 22, 5, so 4. It's negative. give you no, it has to be minus 2 greater. So you have n contains at 0, 0, minus 10. 2 doesn't work. 2 works. No, 2 doesn't work. So it has to be 1. 1 take 10 is 9, minus 9, which is divided by 3. So for the property a equals 0 mod m if and only m. A. That makes sense. A equals a mod a. A equals a mod m. A equals b mod m. That b equals a mod m. A equals b mod m and b equals c mod m equals c mod m. The same as normal laws, which saves a lot of time. Anyways, okay. That equals 2. That 8. Okay, I don't want to prove it. That 5 divided by 11 is greater. No, doing this another day or tomorrow. Ability tests. 2 and only last digits. 10, 5, 10. 10, yep. solving congruence equations. More. You add 5. So 3 times hold the at the last thing. Fermat's little theorem. Cool. Here's a prime number and a not by p, then p minus 1 mod p. Okay. Factorials or just normal numbers. This was a stats question. Yeah, it was a stats question. What next? There should be sets. Groups. What's after groups? Just counting, which I don't necessarily need for step, or at least not this much. That complex numbers are third. Loci in an Argand diagram. That's okay. That's disgusting. I don't have to do that. Where is my mouse? There we go. I can see. Recurrence relations. This is very, very useful. For me, recurrence relations. Yeah, higher sound saving. Plus m plus just modeling with recurrence relations. Okay, that's cool. First order. This is going to be useful to me at the moment. I could ask the step teacher, but he wouldn't care either. I also haven't done the step work I wanted to. Unfortunate. Nice. Romantic Swinsky. What the value of T7? Find term of Tn minus 1 recurrence relation for Tn. Look at the 100 pattern. Okay. Making a function based on the previous. That's so sick. Okay. So it's 5 take 1, which is 4, 14 take 5, 30 take 14. We can represent it as some sequence of m, and you do some other stuff, okay? We have matrix algebra. This you need to learn, but not now. Not this part. Where are you? Where is it? Reducing matrix diagonal form. Well, it's not in the diagonal from top to left, but this is useful. But I don't know how I would do it. Because it came up in a question, I couldn't do it, so I'll just leave it for now. What else is here? Another theorem, okay. more integration techniques. Okay. Reduction formula in your elliptical related to sine squared x. The n integrals low powers with reduction formula. Integral n equal. Cool. I doubt someone will get to this part without being able to do this, but okay. Just normal. Minus stuff. Oh. That's quite smart, actually. It's going to help me now, but I think that's the last thing. That Gabriel's horn. Why is that in here? Okay. That should be the thing before the review exercise. Another horn, that's another horn, okay. And it's over. Oh, I only need 3 chapters max. And I will be done with that. So I just need to go back to learning mod. Once I'm done with mod, I'm fine. That's quite successful. Okay. Barely any progress. Year 2, year 1. Year 1 further pure, there is a bit I need to learn, but I'll leave it for now. And I think I'll stop there. Okay. End of the day. Okay. Bye.